this morning to get ready for school. Okay, so I'm Mr. Koga. How's it going? Chee-hoo. So today we're going to talk about math and adding and maybe even a little bit of subtracting. But what I want to teach you guys today is why does math seem like it gets so fast, so quick, and seems so confusing all of a sudden in school? Now I'm talking to my kindergartners, first graders, and my second graders out there who are jumping into this world of math, but it seems like we don't spend enough time playing with math and understanding what's the differences between all the numbers and all the tools. So we're going to be playing with some stuff today. First thing is this. These are unifix cubes or omni cubes because they can attach in many different directions. They can attach in a straight line. You can make a cube or a 3D object out of these things, but we're going to be playing with these. So these objects have a one-to-one correspondence. That means one thing means one. So I can click them together, and let's say I have 5 and 5. When I put 5 and 5 together, that makes 10. So this is a great math tool, especially for our beginning learners in kindergarten, even TK, kindergarten, first grade, and second grade, because this shows a very concrete model. So the first level, concrete. And with that, I'm going to draw like a little hand because you touch these models with a concrete, they're concrete models. The second one is representation. And then that's going to be more of like the dots and the sticks. When I talk about those, we're talking more about these, the base 10 blocks. So now we're going to make a little connection here because we got the ones right here, right? Whoops. We got the ones, and that is very similar to these. One-to-one. Not a big jump here. But here's the thing that's very subtle and almost invisible that a lot of people kind of miss, especially like teachers even miss this stuff because I've been teaching for almost 10 years and it only clicked with me probably the past year. This stuff really became very apparent to me as a math teacher and an elementary teacher. So you have the ones and the ones there. But then we have these 10 sticks because when we work with numbers, the base 10 model where it goes from ones to tens to hundreds to thousands, that transfers easily and it's a good system. It's almost like the metric system. So right here, we have a 10 stick. The difference is this 10 stick can be broken apart, right? But then, isn't this a 10 stick too? So what we're not understanding, we're pushing them towards these models extremely fast when they need a lot more time to play with these kind of models because this model is break apartable. You can decompose it into its single components, but this one, you have to know that this stick, even if I turn it this way, that this means 10. Now, if I had 10 of these sticks and I clicked them all together, we would get to the next level of representation, which is 100. And again, this makes sense looking at it this way because we see 10 rows of 10, but then when I flip it this way, you just have to kind of know that that big square means 100. And that goes even more so when we start drawing things. So let's say like the concrete model here is, I'm going to put these back together real quick. Here, let's just say 35. That's our model here. So I'm going to build 35 with these over here. So 10, 20, 30, 31, 32, 33, 34, 35. Both of these are showing the same exact models, but this one is much more concrete, and this one is more of a representation of this quantity of 35. Now, the next step of representation would be drawing this stuff. So like for 35, I would draw 3 10 sticks, and then 5 dots for the ones. Now, again, look at the progression. We got the one-to-one correspondence here with the dots or the cubes that can be unlocked and snapped together. Then we have a representation, a model that doesn't exactly show 35 objects, but it represents 35 because you are understanding that this is not just a stick, it represents 10. The final level is abstract. Abstract is all, you cannot touch it. This, I would almost argue, is abstract, but honestly, that is abstract. And you might ask me, what abstract versus concrete? So again, concrete is something you can touch and you can feel and you can play with. Abstract is all in your head. Now, I tell my students this, you look at 35, if you were an alien that came down to planet Earth and you saw that, could you know what that is? Not really, because those are human creations. The number 3, the number 5 is a human creation. It wasn't here when the dinosaurs were around. It's a system that we created to understand the world and to be able to organize ourselves in the world. So 35 is a very abstract concept, especially for kindergarten, TK, and first graders. So my issue with math and with how teachers are kind of teaching math is it's not any one teacher's fault. It's because we're not being really taught in schools, we're not being trained as teachers to understand math at this deeper level. Because it's not deep as in like we're doing like, you know, crazy quadratic equations here. This is extremely simple math, but this is the foundation for strong math people. This is the foundation for people who see math in a connected way, who see math in a very deep way. And don't just see math as this, because this is where we push the kindergartners and first graders and second graders to immediately. We say, okay, here, 5 plus 5, as if that is not an abstract representation. We should be just saying, hey, let's show 5 plus 5, but let's model it. Let's model them with these things so we have an understanding of what is 5 plus 5 doing and why is 10 such a nice, convenient number. Okay, so that's a little math lesson for you guys, and I want to do a little bit of adding too. So let's take 35 and let's add 28 to it, because this is where you see the concrete models really shining. So I got 35 right here. Then I'm going to build 28. Colors don't really matter. Okay, I got 28. Oh my gosh, but wait a second, the ones. I have too many of these guys. So let me take 2 and add it to the 8. So that I made another 10 stick. So now the 10 sticks are all together. I got 10, 20, 30, 40, 50, 60. And I like to organize it like this, where when I have 5s or 10s, I group them because it's easier to count. So 50, 60, 61, 62, 63. So this model, very convenient, because did you see how I clicked them and unclicked them and I put them together? This one in particular right here. That's powerful for the kids, because watch, let me show you what happens when we got this representation. The representation comes in because you have a fair trade or a regrouping that will happen once we get to the ones. Okay, so I got 20, 2, 3, 4, 5, 6, 7, 8. All right, so I got 35 plus 28. Now, this, we already see the problem. There's too many 10s. But here, instead of being able to do the clicking and putting together, I have to do a fair trade. I have to swap them out. So I'm going to take 10 ones, 5 from here, 5 from here. Okay? And then I have to understand that I'm going to trade this for this. That's the power of this tool versus this tool. Of course, this is a great tool and you can get to it at a certain point, but don't force the kids into this. Don't jump straight to here, because this is where they need to swim in and play in, and this is where they will get super strong for 3rd and 4th grade and beyond. Okay, so I did a fair trade. So again, I like to make a pack of 5, 10, 20, 30, 40, 50, 60, 61, 62, 63. Did we just get the same answer? Yup. So that's what we all say in class too. So again, the models, you could see the model. You could see this model exactly how it happened, and I love this because the regrouping is clear. Carry the 1, all that stuff. And that's one of the worst things. A kid comes into my class and tells me, I know how to carry the 1, or I know how to stack the numbers up and do it. That's like, oh no. Because guess what? The kids that can do this can follow the procedure, but they have a tough time mastering this kind of stuff. This will make them fast. This will make them strong and deeper and much better at mathematics. So let's go abstract. So the abstract model, again, imagine you're an alien. You came down to Earth. You're looking at the Earthlings and what they're doing. You see this. A kindergartner could not just look at this and just solve it somehow. You have to know the procedure. You have to know that when I stack these up, this is the 1s, this is the 10s. You have to know that stuff. Otherwise, you're not going to be able to approach the problem. So that's why abstract is tough. Concrete is where we should play in more and more and more. So 5 plus 8, 13. I'm going to put the 1 up here because we created a new group of 10 just like with this trade and just like with this clicking together. So 13 plus, oh, sorry. It's not 13, my bad. 3 plus 2 plus 1 is 63. Did we just get the same answer? We did. Okay, so that was just a little bit of math talking. This is what I talk to my students about, and this is what we play with in class. We look at the different models, and we look at, which one is good for which scenario, and what's the best one for you. You know what the best strategy for you is? Is the one that makes sense. This is not made for young kids. This is not made for older ones. This is not made for adults. Anyone can do any of these, but the key is that you tie them together, you see connections, and you literally weave these things into each other. So imagine these are like threads. You weave it into something that creates a tapestry or this image of mathematics that makes sense to you. So again, kids, don't worry about following the teacher's method. Don't worry about following your friend's method. Make math make sense. That's all mathematics is seeing patterns and making sense. So the more we can do that kind of stuff, the more that we're going to enjoy math. Because when I was a kid and back in my day in the 90s, math was one-dimensional. You had to follow the teacher's procedure. You had to follow what they were doing. Otherwise, you get in trouble. And they would say, hey, you need to follow my way because that's disrespectful. But nowadays in math, math is vastly different because math, we encourage kids to think different. And I celebrate when kids look at math and see it differently. So keep doing your math, guys. I'll be back next Friday with more math time with Mr. Koga or something else fun because I'm trying to get onto YouTube a little bit more. All right, peace. Have a great Friday.